I'm Mike Chipley, my colleague Eric Nickel, and we're going to be talking about your building control systems have been hacked, now what? And for those folks that are interested in the next decade of big money, what do you think the commissioning area of expertise is going to be needed? Cyber, right? How many folks here are either a systems integrator or a controls specialist, controls technician? One. How many do you think we need? More than one. All right. So as you all know, we're going to use the term operational technologies, and these IP-based controllers now are in everything. As the Internet of Things continues to expand, they're talking 200 billion sensors, IoT devices will be in the marketplace by 2020. The vast majority of those are going to be personal sensors and building control systems. And as you can see here from the DoD's perspective, as we started looking at not just our facilities, it's across everything: weapons platforms, medical platforms, tactical systems, manufacturing, our defense industrial base. Every one of these now has an IP-based controller in it. Keep going, next. Keep going, you just saw that. So I and Eric support the Office of Secretary of Defense, Energy Installations and Environment. And again, our role is to provide policy and guidance. And most of the time it's pretty crystal clear, but every now and then we mess up. But I think you'll find that what we've done with the UFC, the TTPs in particular, is the type of policy and guidance that we're trying to advocate for. Next. So back in 2009, when I started working on the program, I'm a retired Air Force civil engineer, so when I retired, then I came back in as a support contractor. So the gentleman that I support, Daryl Hagley, is the government project manager. And so these were the programs that we had running in parallel. So we had SPIDERS, which was a smart grid cybersecurity project, the unified facility criteria. We were assigned to NIST to help write Special Pub 882, Industrial Control System Security Guide. That's the key pub for us, because within the federal agencies, they can't reference to a guideline or a draft. It has to be a published standard. In this case, the NIST standard. Then we wrote a series of DoD instructions, changing out to adopt the risk management framework. And so all of this occurred in parallel. And as you can see, here we are at the end of 2016. Basically, all of these things have now become published, standards, documents, and instructions. Next. The other gentleman I support, Tim Teralt at the ESTCP office, this is the R&D side of the facilities world. This is where we issue project calls for smart grids, smart buildings, smart cars. And so we needed a place that we could put all this guidance out to the public domain as quickly as possible. So we actually just loaded all these documents and the processes January of this year. So if you want to go to two places to get the most current cybersecurity for facilities, is this website and another one that I'll show you, which is the Whole Building Design Guide. How many folks are familiar with the Whole Building Design Guide? All right, so great. There's a cybersecurity resource page on the WBDG that cross-links to this one as well. Next. So as I mentioned, within the Department of Defense, we decided to sunset our old information assurance program, adopted the NIST risk management framework in its entirety so that all federal agencies would be using one system. And so that process took place again in May of 2014. And then our last document, the Telecommunications Networking Guide instruction, was published September 2016. So again, this information is brand new, it's rolling out, it's impacting how we design and construct and operate as we speak. Okay, so within the Department of Defense, have to introduce one kind of a unique term. Remember, we got weapons platforms, medical platforms, logistics platforms. So within the DoD, a unique term, they decided to call this stuff platform information technology. It all has an IT, traditional IT front end, but then down below it, those OT/IP controllers, that's the unique flavor. So again, just recognize, we call it PIT. Next. And here's the definition of what PIT is. As you can see, we were very specific that building automation systems, management, energy, fire, life safety, physical security, these are all forms that will now have to be cyber secured. And when we first did the analysis of this, the CIO has, they are very proud, 8,000 unique applications and IT systems in their portfolio. And they asked us for our count of how many unique platform IT systems that we would have in the facilities. Well, we got 520 some odd major military installations. Each one has 5 or 6 primary utilities. We have 300,000 buildings, 300,000 linear structures like airfields and piers, rail, gas. So you take all those numbers, and we said, well, we think we're right around 2.5 to 3 million unique control systems installed out there. And each one of those has anywhere from 10,000 to 200,000 controllers in it. So we think we have about 3 billion unique IP devices that are now being connected to the internet. So what do you think the CIO thought about that? Oh my gosh. You mean all of my systems that my DoD networks are writing on, you guys have exposed my entire network by your building controllers. Yes, we did. Not intentionally, but again, that's the state of the practice. So here is the new, what's called the Joint Information Environment. We typically would allow contractors, vendors, support contractors to bring their own cables, telecommunications lines, cable, Cox, Comcast, Verizon, et cetera. And then they would in turn connect and manage our buildings or our facilities through those. No more. We're going to require everybody to come through what's called an installation processing node, a network operations security center, and from there, they will then transition out to a special purpose processing node where we will now have an operations center where we can see all of that traffic. So our goal here is to completely put all of our facility control systems completely invisible to the outside world with one point of entry so we can monitor now all that traffic and see what's coming in and out at that installation. Okay, in the Unified Facility Criteria, we published the reference architecture diagram. And for those folks that are familiar with the ASHRAE or the ISA, this is modeled after the ISA. We did a couple of minor tweaks to it. But the key here is this is now called our authorization boundary. It could be the building envelope, it could be a campus, it could be the installation perimeter, but some physical boundary that defines what's inside and what's outside. Kind of like our prior speaker talking about inside weather, outside weather, right? This is the traditional IT front end, level 4, level 5, what we call our platform enclave. And the big key here is traditionally the facilities folks and the facility engineers would buy, operate, and maintain all that equipment as part of a turnkey. So typically if you buy a packaged building and you get that server workstation combination, 80+% of our installed base of control systems right now are running Windows XP or older and cannot be upgraded because they're physically tied to the controllers and the rest of the equipment in that facility. So that presents a huge challenge to us on cybersecurity legacy systems. At the same time, we don't have a test and development environment and we don't patch. Most of these systems never been patched. Would you let your home computer run XP unpatched? And yet we have our control systems on the internet unpatched Windows XP. As I said, we can do pretty good conventional IT stuff up here. Here's our big problem right now, the level 3, what we call the facility point of connection or field point of connection, and then getting all these devices secured. The new malware attacks that are coming out right now, one that's out from Russia is called Black Energy. They are attaching here at the firmware file. So what they're doing is downloading the firmware files off the system integrators websites, inserting the malware code, reposting that so that when the maintenance technicians go out to do their normal maintenance, they upload the firmware. The firmware now gets here and comes up to the next level 2, level 3 devices, opens up an outside port, and communicates to a command and control channel beacon, and then they import more malware and then completely take over the system. So again, that is the state of the practice that we're dealing with. Next, please. As I said, here's in the Unified Facility Criteria, our definition of planning, programming, design, construction. So this is our new life cycle. We now have to plan for 40 to 50 years of how we're going to budget for doing cybersecurity, because it's not just that we built and delivered the system. Now every month we have to do security audits, we got to do patching, we got to do system upgrades. We're no longer going to let a building keep a Windows XP machine in operation for 10 years, 15 years. We're going to want to continuously modernize that and build that process in. As I mentioned, NIST 882, published May of 2015. It takes the original NIST 853, which is the master for IT systems, but the family of it's called security controls are exactly the same, but we have what are called supplemental guidance. So for example, how many folks, business rule, if you're at your desktop and you walk away, what's supposed to happen after 10 or 15 minutes? Screen lock, right? Do we do that on control systems? No, typically not. So what the supplemental guidance says, instead of 15 minutes after inactivity screen locking it, use two-person control. The computer workstation server stays on at all times, but somebody's always there physically sitting at the machine. Or if that's not possible, have one person in a locked room with a CCTV camera that can ensure that no unauthorized access of that workstation occurred while that person wasn't there. So again, that's how NIST 882 works. We specifically put in, because of the word industrial control systems security guide, most folks associate that with manufacturing, gas, transport type of systems. We actually added now section 2.5, other types of control systems, so that you can see that this can be applied to any type of control system. It's flexible and general enough. The practices and the guidance can be applied to any control system. Here's some of those key families that I mentioned. Configuration management, program management, planning, secure communications, contingency planning, acquisitions. And again, when we were writing the 882, the mantra of the security team was we wanted to have inbound protection, meaning get it into an enclave, get a demilitarized zones, traditional IT firewalls, those types of things in place. And then outbound detection. Do I expect a building controller to open up a port and start sending large megabyte files to China or Russia? No. And so it's, again, control systems usually respond and communicate in very predictable, very normal ways. And when we see abnormal behavior or abnormal connections occur, then that's a flag that something's going wrong. Okay, again, our trick here is somebody has to be looking. And that's what we're trying to do now, is get the workforce in place to begin doing the actual monitoring of the systems. Next. Okay, there's the group of folks. We also work very closely with the Department of Homeland Security's ICS CERT team. There's two components. US CERT is the IT side of the house. ICS CERT is the OT side of the house. It's a 24/7 operation that's run out of Arlington, Virginia. But then they also develop a tool called the Cybersecurity Evaluation Tool. And what we do is we program in not just the DoD, but TSA, pipelines, chemicals, any other standards organization. The standards are put into the CSET tool, and then it has many, many powerful capabilities. Lots of reference documents that you can see there, as well as then the CSET tool has Visio embedded in it for free, so any business can now use this small, moderate, medium-sized businesses in particular, have the full capability of a true Visio platform. And at the end of it, it actually generates now what's called your system security plan, the key very first document of doing your risk management framework process. It has your network architecture, your inventory, you answer all those security control questions, and then it really then is the basis document. Next slide, please. Here's what the Visio diagram comes with lots of templates already built in. We've added a tremendous amount of additional devices, components. This last round, we added a huge number of medical and radio components. So again, you can use the templates, custom build it to your own. Next. Our biggest problem, as I mentioned with the legacy and that Eric was showing, was we didn't have an inventory of these systems out in the field. And then, of course, as time goes on, you're doing normal maintenance and repair replacement, all those endpoint devices are getting changed out. So we don't even know how many endpoint devices we have. So we got with our friends at NSA, and they developed a tool called Marlin. It's a passive network discovering tool. It uses a very common product called Wireshark, open standard, and it does packet capture of those IP packets. But then what we did is we got with our vendor community, and we asked them to give us their footprints of what their make, manufacturer model, communications protocol, et cetera, would look like. And the vendors, we're up to about 250 footprints now, adding anywhere from 10 to 20 a month more. But what Marlin does now is let you very quickly get an inventory of what's actually on your site or out in the field, up to tens of thousands of devices. And then you can import the results from Marlin right into the CSET tool, so now you can get a really good-looking, high-quality Visio network architecture diagram. Next. All right, so procurement challenges. Can everybody see the original boat is change order and the dinghy's the original contract? Like I said, the next big era of money. So Wanda and I were actually on a call today with the government agency that we're building a very large brand new headquarters buildings for, and they've now going to have to go implement all the stuff that we're talking about, but it's going to require a contract change. And I'll be at the Army Corps Savannah next week doing a workshop, same thing. We're going to be, the contracting officer's already told all his folks, get ready, prepare, because we're going to have to issue contract mods. We've got to include cybersecurity requirements into all the contracts going forward. Next. I mentioned that we have a couple of folks that raised their hand, but what we need to have is everybody in this room with a basic level of cybersecurity training and awareness, and then we're going to have to build a skilled workforce over time that is now going to be your designers, your A&E, your construction companies, your system integrators, and then ultimately a cadre of trained information assurance facility engineers. They're going to be sitting there watching these systems in real time, and if abnormal behavior occurs, they'll take actions to stop and detect and repair it. The first thing that we did then to address the workforce is a new instruction called 8140, and it now authorizes the DoD to go out and train all these folks against these new skill sets. Next. The federal government as a whole has now adopted what's called the NIST National Initiative for Cyber Education. They're extending this to the university, community, college, high school level, so that they've defined a predetermined set of skills, certifications, and training that they want these folks to have. And then every federal job position now has a requirement for what level of training and certification they will need to have for their job. So again, training is now key to making this happen. If you've not seen any of the announcements on cybersecurity training, or you want to get involved again, NIST is the place to go. Next. Here's some of the skill sets that we've identified for the facilities community, which is primarily facility engineers, facility managers, emergency managers, physical security specialists, our series of technicians. So again, as you can see here, There's a whole lot of new terminology, vernacular, that the folks are going to have to learn. And at the same time, our traditional IT information assurance folks that protect the IT and telecommunications network now have to learn the terminology of building control systems. Next. Here's the new unified facility criteria. So once the UFC is published, it is in effect for the DoD, the law of the land. It took us almost 5 years to publish this particular document. Remember that chart I showed you, all those things going on in parallel? But what the UFC says is use 882, the NIST standard, and then apply it to your control systems at the design phase. Now, I want to make a point here. Any organization can use this unified facility criteria. We wrote it so it was extremely general flexible that you can then take the word DoD out, put your organization name in there, and then you should be able to use the design criteria for any facility control system. Next. The UFC is more at the high-level general guidance. We then realized that we needed to write another guideline or several that would take how to do the actual step-by-step. So here is what we call the Information Assurance Guideline that we just published in January. It's up on that ESTCP website that I mentioned earlier. And then this one now has project roles, responsibilities, requirements for subject matter expert, test and development environment. As I mentioned, right now in our legacy world, we don't have a test and development environment. So why the reluctance to patch a machine, a production machine? Because there's nowhere to go test the patch to make sure that the patch is installed doesn't conflict with either other vendor products or the operating system incompatible with the other equipment. Next. So here's the language that we're putting into. We started with our ESTCP fiscal year 2018 R&D projects. So this is now going to be similar to what you should start seeing in your construction and operations and maintenance contracts. So again, this is coming back to commissioning specialties. You're going to want to see about bringing or getting these types of certifications. Next. Here is the requirement to establish a test and development environment. For every project now going forward, there will be a test and development environment that we will then transition as the project goes on over to the owning organization so that then as they build their master test and development environment, new projects will come in and it'll just be absorbed in. But again, we're going to pay for this up front initially, but this is going to be a major change in how we deliver systems. A couple more terms here to get used to: factory acceptance testing, site acceptance testing. So again, basic commissioning type of process. The two checklists are on the ESTCP website. Download them, get used to the terms, figure out how it's going to fit into your business model, because this is the decade of big money in commissioning. This is how we're going to do it. For fully mission capable baseline, I'll talk about that a little bit later in a jump kit, but if we lost a control system right now, we don't have backup copies of the firmware, the software. We might have a backup copy of the database, but we really don't care about that so much as if the system is totally exploited, malware, ransomware, we're going to have to wipe the system clean and do a fresh install. That is what the jump kit rescue is going to do for us. Next. Here in the Information Assurance Guideline, again, we're calling out specific contract language, required submittals, jump kit, and that's what it is. Next. Okay, so up until now, we've been talking about how to get the design, construction, system integrator community ready and prepared for this new cybersecurity posture. Now we're going to flip over to the next piece of the puzzle. Was we actually had within DoD a number of compromised facility-related control systems. We had compromised ship and submarine platforms at sea. So when we say the threat is real, it is not just real, it is active. In fact, most folks in this environment now are saying, don't think that your control systems are safe or immune. Assume that your control system is now and has been exploited for, if not the last year, probably the last couple, 3 years. What was the last one that we saw with the ICS CERT? It was 443 days, I think.
It was around there.
It was around there.
I think it was 445. Yeah.
445. So ICS CERT is part of their report. They just found, the longest one that they found now, 400 and some odd days that the aggressor attacker had been in that system and been exfiltrating and owned the data. Next. Okay, so again, here's the breakout of the TTPs, detection, mitigation, recovery, routine monitoring of the network, and then specific procedures that you'll go through to actually detect and respond and mitigate. Now again, most of this is related to the traditional IT front end. So how many folks even know how to open up in your Windows machine right now, go to control panel, hit components, and then go look at your Windows log? Huh? Has anybody done that? Okay, we got a handful of folks, right? Again, most folks don't even know how to do those basic steps. So what the TTPs does is it breaks it down to, here's how you actually do it. Next. Okay, when our IT and ICS managers remain in close coordination. And so within the DoD, they're actually now co-assigning the CIO and the facilities folks into a joint organization. So the Navy, NAVFAC, Facilities Command, CIO, the facility engineers, now they're a joint organization. Air Force Civil Engineering Center and the Air Force Cyber are now 24 Cyber, now a joint operation. So again, this is what we're starting to see. On the private sector, that model's not as easy to replicate, but we're probably going to see some sort of a commercialized product come out of this, very much like the McAfee's, the Nortons, the Force Points. There's going to be somebody that's going to provide this as a service for traditional facilities, commercial office space, commercial properties, that type of thing. Next. Okay, the FMC baseline to determine normal operational conditions versus anomalous conditions. And so you'll notice in the UFC and the TTPs, we state at all times the intent here is to be able to operate the systems in degraded mode. Do not turn off the control system unless it is you're completely incapable of even maintaining degraded operations. So we do not want to depressurize the grid. We don't want to the water system. We don't want to de-energize the grid. We don't want to shut down the building control systems, fire, life safety, physical access control, et cetera. At all points, again, try to operate in degraded mode at all possible. If you have to wipe everything, that's where the jump kit comes in. Next. Here's again the logic flow chart of the procedures. Next. And then here are the step-by-step procedures again. So the irregular process is found. All right, jump over to page A7. And unfortunately right now, they didn't hyperlink all this stuff and it's not computer checklist set. So literally we have to sit there with a notebook in our lap and flip pages. But that's, again, part of our next steps is to turn this into a more actionable machine-to-machine process. Next. So now you flip over to that, determine if the new process belongs to an authorized installation, something just went wrong, does not belong. Then you go to document, here's the recommended checklist. And so again, there's specific checklists for each of those on how you actually check the server, the workstation, the controller itself, on down the line. Next. Again, if you're working on the traditional front end, Microsoft Windows, fantastic set of tools that Microsoft put out there that just so few folks know how to even know about them, and then number two, how to use them. But again, highly recommend that you get in particular Auto Runs, Process Explorer, Process Manager. Those 3 tools will give you insight into your systems that you've never had before. Next. Okay, again, so here we're running Process Explorer. And so what it does now, it's like the old Control-Alt-Delete Task Manager, but it's on steroids. So now it brings up all your threads, all your instances, what's executing, and then what it's connected to downstream. You can get all your performance statistics. Again, so indicators of compromise. If all of a sudden you're running high CPU, you're running out of memory, disk space, all those types of things, SYSINTERNALS begins to let you do. And even better, if I right-click on this instance, this service, it gives you the opportunity to suspend that service. So now you can see if it's malware, potentially masquerading as a known file, and then you can trace that thread down, so now you can actually root out the bad stuff. Next. One of our favorite new tools is GLASSWIRE. So for those folks that have a home or a small business network, it's nearly impossible to go look and see what your machine is actually doing, what services it's calling, what IP addresses it's communicating with. So GLASSWIRE is a free tool. It's also got a paid version, but particularly for small, medium-sized businesses that can't afford the big dog tools, this is a marvelous tool. It does firewall, does your usage, does your alerts, and it logs it all as well. So now I can see every time what IP address it's going to, what service it called, and what version. Next. All right, so again, that's part of baselining and getting your original inventory and configuration set up. Now we're going into the mitigation concepts. Again, so you've been exploited, now what do you do? So next. We'll require vendor assistance. What the DoD is trying to do now is establish flyaway teams. So Cybercom will be the point of entry. You'd contract with them, and if you are on the flyaway team with a particular expertise in, say, Tritium or Johnson Controls or Delta Systems, those vendors are going to have to be there and run through these TTPs because they're the only ones that have that in-depth system knowledge of that particular product. So again, an area that's going to explode over time. Next. Okay, maintain primary power, save an image of the drive in volatile memory. And we'll show you a tool here in a moment called OS Forensics. So the first thing we're going to ask you to do, if the system's been exploited, you know it, save a forensics copy off to the side, and then try to repair the system best you can. If it's not repairable, again, start with the jump kit, install it from scratch. Next. Okay, monitoring procedures. And again, we've specifically broke out Windows XP versus Windows 7 and higher. Next. Here's how to use Disk Manager, particularly for folks that have got Windows 7 and newer. How many folks have gone into Disk Manager to see how many hidden drives are in your system? One. Okay? So if I'm the bad guy, and all you think you have is the C drive and maybe one other drive over here, when you open up Disk Manager, you'll see that Windows operating system actually has several drives hidden behind the scenes. And do you think your continuous monitoring software is looking at those hidden drives to see if malware is embedded there? Nope. When you do that scan, it says scanning C drive, scanning the D drive. Okay, and again, another best practice here is separate your operating system and your data drives. Okay? The malware typically goes after the operating system, and they're trying to find your data and then exfiltrate that. So what I do is I've got my data drive as a separate drive, and then I install and use BitLocker, so this drive is fully encrypted at all times. If they hit my OS, install ransomware, hopefully I'll catch it before they can get to my data drive. And even if they do, they still have to get through my encryption or Windows encryption on that data. So again, some best practices there. Next, please. Here's the forensics. And again, we're going to say anytime that it's attributable to a human root cause, then it's going to require an incident investigation, and now you're going to have forensic specialists. So if you are a business supporting the DoD, you are going to be required to do these same things. So you're now a point of entry, just like the HVAC contractor was the point of entry into the target system, right? Doesn't matter how they get there. If you've got DoD or federal government agency data or private sector data, and they've come through your system and attacked and exploited them, you are now potentially liable for that data breach. So how many folks have gotten your insurance riders that now has the cyber breach protection with third-party forensics rider? That's available. It's only been out for about 1.5 years, 2 years, but you might want to start looking at that as part of your insurance. Okay, next. Here's OS Forensics. Again, it's a free tool, or you can get the paid version, but I highly recommend everybody run OS Forensics on your personal or business machines, particularly if you've gotten a machine that has been repurposed or from another person and then comes over to you. You will be amazed at how many browsers are going to retain passwords and links to all those accounts. And again, if you want to check on what your kids are doing, it's a great way to see what they're doing. But again, it's very technical. It'll tell you exactly what your machine's doing, what the Windows registry values are, or where those passwords are stored so that you can delete them out. Next. Okay, so again, all federal agencies are required to report an incident to the U.S. CERT. Here is the incident reporting form and a scoring system. As of April 1, a brand new form just went up. It is mandatory for all federal agencies and federal contractors to use that form. So again, if you're not familiar with it, not seen it, download the PDF and then build your security incident reporting form to match that. Next. There's the incident reporting that I just mentioned. Next. And there's the whole building design cybersecurity resource page. So if you're a complete novice to cybersecurity, here's your Cyber 101 primer. Start with this, go to the ESTCP website, download all those other documents I mentioned, and then give Wanda, Eric, or myself a call when you need somebody to help decipher this terminology in the vernacular of the next 10 years.